Now we take another example to determine the most powerful test. Let x has the observations from the density f of x. Test the hypothesis h naught, that is the f of x, that is f naught x, that is the one density, under the alternative hypothesis, that is f of x, that is f of 1x, where the f naught actually defined in two steps, that is f naught x, that is x between 0 to 1, and 2 minus x between 1 to 2. And for alternative hypothesis, the density is that is 1 over 2, and it is from 0 to 2. The objective is that find the most powerful test with size alpha. So let's see how we proceed. This is some sort of different type of example. Here we actually stating the null hypothesis and alternative hypothesis for the densities. So let's see how we develop the most powerful test for this one. So according to the Neyman-Pearson's lemma, by considering the densities at a point, there is no problem. अगर आप एक पॉइंट पे भी डेंसिटी को यूज कर लें तो इसमें कोई ऐसी इश्यू वाली बात नहीं है. So let's see by using the Neyman-Pearson's criteria, that is actually the ratio of f1x over f naught x, and this is equal to 1 over 2x for 0 less than x less than 1, and the other one is that is 1 over 2 into 2 minus x. We just divide only 1 less than x less than 2, and it should be greater than or equal to k. Or from here we can easily find the value of the x. So if that is 1 over 2x greater than or equal to k, or x can be less than 1 over 2k, and that is for 0 less than x less than 1. So we need the probability 0 less than x less than or equal to 1 over 2k, and this can be easily find out by using the densities, that is 0 to 1 over 2k x dx, and by evaluating this we can get 1 over 8 k square. Similarly for the others, that is 1 over 2 into 2 minus x greater than or equal to k, which implies that 2 minus x less than 1 over 2k, and from here you can easily find x is greater than 2 minus 1 over 2k, and that is for 1 less than x less than 2. Now we need the probability of x greater than, that is 2 minus 1 over 2k, and that is equal to 2 minus 1 over 2k up to 2, that is the density, original density 2 minus x dx, and that is equal to, इसको भी अगर आप evaluate करेंगे you will find the same result 1 over 8k square. Now we write down the size condition of type 1 error. Now the size condition of type 1 error is, that is under the null hypothesis, that is 0 less than x less than 1 over 2k, under the interval, that is 0 less than x less than 1, plus the other situation, that is under the null hypothesis, that is x is greater than 2 minus 1 over 2k for 1 less than or equal to x less than or equal to 2, and that is equal to alpha. And we know that its probability is 1 over 8k square plus 1 over 8k square, that is equal to alpha, and this implies that 1 over 4k square, that is equal to alpha, and this implies that 1 over 2k, that is equal to under root alpha. So the Neyman-Pearson's test of size alpha for testing H0 versus H1 is reject H0 if x is less than under root alpha or x is greater than 2 minus under root alpha by using the original densities. So this will be the criteria. Now we take a practical example so that you can see its practical use. Suppose that alpha is 0.01 and under root alpha will be, that is 0.1. So to test the test will reject H0 if x is less than 0.1 or x is greater than 1.9. So any value of x is reject between these two limits, that is 0.1 to 1.9, and the other of this limit, that is we accept H0, otherwise reject it. So the any value which lies between these two limits, we accept the null hypothesis, and any value which falls outside this limit, we reject the null hypothesis.